Okay, so hi everyone, and welcome to the second episode of our new series, The Future of Urban AI. The Future of Urban AI is a series co-produced by Urban AI and Cornell Text, for which we are exploring several possible futures of urban artificial intelligence. So during 10 episodes, we will explore with worldwide experts several topics such as quantified canopy, augmented urbanism, augmented maintenance, and geopolitics of smart cities, and Internet of Nature. Just to let you know, for this series, we were inspired by the future of urban tech, which is really an amazing project realized by actually Anthony Tenson, who is with us today and his team, which through a kind of dynamic graph is proposing several possible futures of urban tech. And basically what we did is to explore AI-related signals from this graph. So if you want to explore it, you have the link just here. But for today, we have the great pleasure to welcome Kris, co-founder at Telraam. And today we are going to talk about how technologies and actually urban sensors can be used to empower people and communities. So first, we will have a presentation from Kris. It will be a 20-minute presentation, and then we will have a Q&A session. For the Q&A session, you can either directly ask your question on the chat, or you can directly ask it to Kris. If you want to open your micro, I will just ask you to virtually raise your hand before to ask your question. So now let's start the episode. Kris, the floor is yours.
Right, thanks a lot. Thanks for the introduction, Hubert. Dialing in from Belgium here. Nice to see that this is like truly a global event everywhere. Right, so like Hubert said, I will take the next 15 to 20 minutes, probably 20 minutes, sorry, to talk about Telraam and a big project that we did with Telraam. First, a bit of background maybe on myself. So I've been working for 15 years now, 15 odd years as a transport policy specialist. So data-driven consultancy close to university, but always using data to give policy advice, anything related on transport. So impacts of new roads and so on, anything which requires lots of data. And that's where the project and Telraam started from. But let's dive in. Let's see where AI kicks in, and let me explain to you how we went about and what this project is about. If this would be a live event, I would ask people to raise hands. Have you ever heard of Telraam before? And just to get an understanding if people already, if we're getting some exposure, but it will be a bit difficult now, I think. So the title is WeCount, which is a project empowered by Telraam, which is the technology. With a handful of titles enabling citizens to initiate a policy-making process with fully automated traffic data collections. In short, we want to engage citizens to collect traffic counting data and act upon it, analyze and act upon it. That's what we did in WeCount, and that's what Telraam is for. So first of all, making this clear distinction. So what's WeCount, what's Telraam? So first of all, what's Telraam? Telraam is this thing here on the right. It's basically a traffic counting sensor installed on the inside of a window. If you look at the camera, it's this small thing here. It's a Raspberry Pi based system. Raspberry Pi, probably well known to most of you. If not, it's a small off-the-shelf hardware mini computer, which is cheap, which is used for rapid prototyping and which is used for a variety of applications. We've used it. We've written software so that it can detect passing traffic. It's not just a sensor; it's also an open platform. So if you haven't already, check the website www.telraam.net, which is basically a map with all the data that's being generated. And it's this combination which is crucial. So you got the sensor, but it's also an open platform. It is allowing to continuously count traffic of 4 modes of traffic, so not just cars, but cars, pedestrians, bikes, large vehicles, and side bikes. And it has to be installed on the inside of a window, connected to the power, connected to the Wi-Fi of the host. And in that sense, it's true citizen science because these devices are hosted, owned, adopted, whatever you want to call it, by citizens. And it's not just data which is being collected by citizens, it's also data interpretation. And I'll come to that later, but that's the core of Telraam. Now, what was WeCount? So we started with Telraam 2018 as a small proof of concept, I think, and then along came a European project, WeCount, under the Horizon program, Horizon 2020 at the time, under the SWAFS program, which unfortunately doesn't exist anymore. But this allowed us to scale up and to improve the technology for using actually this type of technology much better in a citizen science setting. So we basically tried to embed Telraam in like the full chain of citizen science: data collection, interpretation, co-designing, everything. So we had quite some funds to do this in depth, to do this properly, and also include as many people as we possibly could. So the WeCount project was in 5 cities: Dublin, Cardiff, Leuven, Ljubljana, and then the tandem Madrid and Barcelona, so European cities. The aim was to install 200 devices in each of these pilot cases, and then apply them in their own local context. So, for example, I think Ljubljana wanted to use it to monitor active travel. In Leuven, the case was a more circulation plan, so major changes towards circulation. Madrid, Barcelona was more on speed. Cardiff was more on low traffic neighborhoods. In any case, different applications for the same type of tools. And in different cultures, which is also quite different how to deal with citizens. It's not the same in Barcelona as compared to Dublin. So that's the distinction, that's the difference. We'll first dwell a bit on the technology, explain a bit how we make this sensor and how this platform works, because urban AI, so I think there's a bit of tech here that I need to talk about. Like I said, so with the current V1 sensor, and I make this distinction explicit because we're making a new one. So the components of the existing sensor is the Raspberry Pi, and more specifically the 3A+. It's compatible with any Raspberry Pi 3 and not the 4. But we're using the 3A+ because it's the one which has the best value for money. It uses a camera-based system, so that's already alarm bells, private camera, citizens, so that means privacy. We'll come to that. And then we have software, obviously, which is all pushed on the small micro SD card. Basically, with the first V1 sensor, we're using open existing scripts. Basically, you have to tweak only existing packages. It's OpenCV Python that we've been tweaking towards this application, and everything is then pushed towards a cloud-based system for which we rely on AWS. This is all, let's say, the past 3 years or so. This is new, so we're developing a completely new sensor which is custom built for this application. So as you can see, there's a custom built PCB printed circuit board which is really made for the application of traffic counting with citizens. It also includes a screen, and it's still playful, so as to engage citizens. You've seen the original sensor. It's a black box with a cable. I mean, it's nice if you're a tinkerer. It's nice if you like tech, but it's not nice if you want your window to be clean because this is installed on the window. It's not very engaging. So we redesigned it a bit to also have an engaging element and have this screen on top. What's different here as well is that this is truly an AI-based system. So you might have heard of YOLO, so the existing neural networks for image detection. Well, we're making a pruned, very simplified YOLO for just traffic detection on a constrained device, on a very small, cheap device, cheap piece of hardware, as to keep the cost low. That's important. If you're talking citizen science, cost has to be low. It has to be a commodity, and that's what we aim to do with this sensor. We're almost there. This one will probably launch in the next 3-4 months or so. A bit on the technology. I hope that this video works. So the existing technology for the V1 detections, basically there are 5 steps, of which the last one I'll ignore. So there's object detection, object tracking, object classification, and then the data collection. And the current sensor differs from the new sensor. So what you're seeing here on the right is how the current Telraam device sees passing objects. It's currently using background correction, so it will take a picture every 3 minutes over a 13-second period of time, and will compare each frame versus this background. If there's a difference, then it will detect an object. This object is visible for every frame, and then you have to obviously track that. So is the object in frame T+1 the same as the object in the frame T? Obviously, there are existing libraries to do that, and we've used to the max the existing tools to build that. So that's how V1 works, and this happens on the edge. What do we mean with on the edge? On the sensor itself. So I think the classic technology, or at least the one from the last year, the previous technologies are to collect data, are to collect video material from a camera-based system, send it to a central backend, and then have like a very strong PC for image recognition, and then do whatever you want to do with it to collect the information that you want. We're not doing that. We're doing this on the edge. So we're doing what the device can do, because it's still cheap, so you have to be careful. It can't do everything, but what it can do, we'll do it on the edge, and that's the Raspberry Pi. And then only send the information towards the backend for further processing. This is privacy by design. There's no image leaving the Raspberry Pi-based system towards our backend, which is very important, at least in Europe, and also for our citizens users. Okay, I'll go next here. So the next part here is then the classification. So what we get out of the V1 sensor is objects of different sizes. We basically use about 3 or 4 parameters of these object properties to then allocate them to a certain class. Axis ratio is 1. So for example, a pedestrian is very small, very tall. Axis ratio is about 5. It's 5 times as tall as it's wide. A car axis ratio is 0.5. It's 2 times as wide as it is tall. But you have also other parameters like relative size compared to each other, speed, location on the image. So there's a few parameters where we can play with, and we use that to use a more complex, more difficult, heavy lifting algorithm to then classify these objects from object properties towards car, pedestrian, cyclist, or large vehicle. You can see some clouds here on the bottom right. To give an illustration how we're using some hill climbing algorithms for doing that. Now, the future is AI, obviously, urban AI. I think it's well within scope of the program. The future is AI. With the emerging technology, there are now quite affordable hardware chips where you can run basic to already quite complex neural networks on a hardware device, and we do everything together. And that's what we did in the new sensor. So in the new sensor, we have a hardware chip which is designed for AI algorithms, AI scalable neural networks. And yeah, that's what we're using for those who are interested. It's a Candrite K210. So if anybody's knowledgeable about the hardware, that's our hardware platform, and then everything built around. So everything is done in one go, basically. What's also very important in terms of difference between the current sensor and the new one is data connectivity, data connection. It's an IoT device, so it needs to transfer the data somehow. With the Raspberry Pi, we're quite limited in options there, and we've opted for a Wi-Fi system, which is far from ideal because Wi-Fi is notoriously unreliable. So, I mean, it can disconnect. Raspberry Pi does not like the 5 gigahertz network. Sometimes you don't have this available. I mean, there's plenty of things which can go wrong with Wi-Fi. So with the new sensor, we've got something called ThinkStream, which is basically an IoT communication service provider, which is completely simple. So I mean, it's got a SIM card, very small data packages sending over, very cheap, and no worries about connection with the Wi-Fi. So that's a bit how our sensor architecture looks like. I'll ignore a bit on the data storage visualization because it's a bit more trivial, and I invite you to go to the website. You'll see the telraam.net, the map, what we are producing. Now, this is, of course, the crux, the key thing. We're doing this together with citizens. This is an indoor device. This is not designed for outdoor. This is not designed for installation by an expert. No, it's designed for hosting and installation by citizens. And not just any citizen, everybody. I mean, 70 plus, 15 younger. I mean, it has to be simple and accessible for everybody. And this opens a lot of benefits. For one thing, already quite simple, the cost of installation. If you have to do traffic counting installation now with a pneumatic tube, a high-end camera system, whatever, you'll need a trained technician who has to go on site to install this thing. There goes already €200-300, if not more, for just one installation. Here you have participants who are volunteering to do this for you. And so the quid pro quo is, I do the effort to install the sensor and I get data from my specific street, which I can act upon. That's already a big saving, but that's just where it starts. So the citizen can contribute so much more. So I've been analyzing traffic data for 15 years. I found myself in many occasions that I've been looking at data which I could not interpret. I could see that there was like a spike in traffic for whatever reason. If you have a citizen who knows the local context, she can interpret, also can help you interpret data. And that's what you need to do. You need to involve also the citizen in interpretation of the data. If there's been roadworks for whatever reason, you can see like the spike as an agnostic expert, let's say. But the citizen can interpret and you can say, okay, but this spike came from, I don't know, School Street a bit further down the road, or roadworks or whatever. And what I think is the most interesting one is this bridging of the gap. So we have a lot of activist users with Telraam, so who want to use to demonstrate a specific problem. With Telraam data, you can objectify this discussion. So then now there's finally data to have a discussion about. So it tries to negate this antagonistic relation between a citizen and a local policymaker, who the citizen is looking at to do something about the speeding in my street. Now you've got data which is common ground where you can have a discussion about and then find a solution. Got some nice examples about that as well. And this is I think the foot in which is really nice on the citizen science side. Again, I'll speed up a bit. I want to talk about WeCount. So this is the screenshot of our website. Again, I invite you to go to the website telraam.net and you will see basically all these kind of dots and segments which light up. You can find the data of all of them. And this open data platform is really crucial. So if somebody, if a citizen decides to join Telraam, he basically agrees to share his data, his traffic counting data, not his personal data, traffic counting data. That's the quid pro quo. And so, okay, you can join Telraam, but then you have to share also your traffic counting data for everybody to use it. And there's an easy, simple interface on the web app, but there's also an application for techie guys. So this is just a screenshot from the API. So this is not just for people who just want to interact with a website. No, you can also just call the full data set and do some own analysis and whatever you want to do. So there is an API for that, which is open. So that's Telraam, traffic counting sensor. So existing Raspberry Pi one, and a new, much more fancier new one with a custom PCB sensor, the citizens in between, and then the open platform with the data where anybody, policymakers, academia, citizens can use this data. Now, what was WeCount? WeCount started in, I think, end of 2019 for a 2-year project. And it started a bit out of a personal frustration out of mine, because I've been involved in quite a few citizen science projects, and I'm super frustrated that all these projects die when project funding dries out. And so you have to chase funding after the other, which is not sustainable. I mean, you have to find a solution where you can have like, where you can kickstart a community, which is then self-sustainable afterwards. And that's basically what we try to do, with WeCount. Can we set up a self-supporting citizen science community? Can we build this ecosystem so that we're out of the loop, that people can start working themselves on these issues? I'll quickly explain what we have now identified as the WeCount method. This is less AI, but a lot of citizen science. I think it's of value still, and it's really one of my pet projects. I really enjoyed the time, although it was pretty heavy. It was during COVID time, so try to do a citizen science project in the middle of lockdown and pandemic, not easy, but I think we, given the circumstances, we did well. In any case, citizen science method, there's lots of literature on how we should approach it. We've got distilled this for WeCount. So there's 5 steps, basically: the scoping, the community building, the co-design, the data collection, the analysis, and then the reflection and policy impact. And citizens are involved in each step of the way. So first of all, your scoping and community building. Obviously, there's the geographic boundaries. So we had these 5 pilot cities, so Leuven, Madrid, and so on. Leuven, Madrid, Barcelona, Cardiff, Ljubljana, and Dublin. And you have to reach out to people to know about your project and want to be involved. It has to be broad, all stakeholders, citizens, but maybe also the policymakers who could use the data. Academia could work with the data and do some more in-depth research about it. So that's the first thing. We've used a myriad of techniques. So we had quite some press, so we could get a lot of people on board and interested in the project. What we learned there is that at least for traffic count, but I think it's probably the same with many citizen science projects, the quid pro quo for citizens. So the reason why they opt in is not just getting a free device, but they get data for their context, for their living situations, for their street, and that's enough. So they want to do an effort for that. You don't have to pay them. They are willing to do this effort of installing the sensor if they get a bit of extra, namely this data. So we didn't really have any issues recruiting participants. Now, the second part is obviously, if you're familiar with these research projects, you have to be very clear on what you want to do. So you have to be as specific as possible, and you have to do co-design. But obviously, we went into the project with our own idea of what we're going to do. So in Leuven, we're going to check on the impacts of changing traffic circulation. In Cardiff, we're going to check out low traffic neighborhoods. But you have to truly open this up. So you have to do true co-design. So that means discuss with people what's interesting for them. So this already led towards the rescoping a bit of the Cardiff case towards speeding. And if you don't allow that, if you're rigid in your approach and you want to stick to what you think is needed, then you will lose people. You have to truly open this up, which is annoying because it's more work. But it really helps with engaging, and people will. There's a big return on that because they will also start doing much more work for you that you don't have to do yourself. So again, our approach there was surveys, lots of talks before we started with the project on, okay, but what's valuable here, what's going on in this neighborhood, where should we definitely measure and for what reason. So that's what we did in the co-design, and not just on the what we want to get out of there, but actually we also tried co-design on the sensor side. You can see it here on the bottom right. What can you do if I don't have a window available? And you actually had people who designed an outdoor variant where you could install the Telraam in an outdoor variant and share this with other participants. We now have a nice blog post of I think 5 examples of outdoor variants of this device. There's also somebody who redesigned the camera mount, because the previous one, which was like an off-the-shelf thing, wasn't really useful. So he designed something new with 3D printer, shared his 3D printing files, and allowed others to print their own. So again, you can engage at different levels, and this is the extreme level of really making your sensor together with on the hardware. But this is possible, and this creates a really nice community. So third part is the data collection. So in our case, it's this sensor. So it's a sensor installation by citizens. That was what we done the same. So we had a quite smooth, simple, I would say, onboarding process where people register, they get instructions how to install, and so on and so on. But there were some variations on how we approach it in a different city. So for example, in Leuven, we did hybrid workshops where people would come to. We would give them instructions how to install, explain it every step of the way, and then hand over the device and leave it with them to install. In Cardiff, we were a bit more handheld, let's say. So we went on site at each participant to help with installation if needed. In Dublin, it was the other way around. We just distributed via mail and only online workshops. So you can work with different ways, but the key thing is that you do sensor installation by the citizen themselves. If you don't do that, I mean, then you're going to lose a lot of time. You will require a lot of effort, and then the citizen science element is also out. So the key thing here is to make it as simple as possible. So this is what a bit has driven us towards designing this new sensor so that the installation is easier, because here you can really see who drops out. Non-educated people who are very willing and very activist, but just don't manage to install a technology like this, which is a real shame because they're really willing to do an effort, but yeah, they just can't get it work. What also nice here in the margins that we try to set up peer-to-peer support. So that means that if in the neighborhood there's like a techie guy who knows what the Raspberry Pi is, knows how to install, and there's like a 70-year-old who also wants to install, but doesn't manage, that we bring them into contact, and that the techie guy can support the elderly who is not familiar to install. So all these elements, I mean, that's community building, and trying to make sure that people can help each other for sensor installation. Now, data analysis and awareness, and this is what I like the most, because you would say, oh my God, now you've got 500 devices or more collecting data, and now finally you've got data to mess around with. And obviously we did. We found very nice examples. There was one particular example of in Leuven where there was changes in the circulation, and there was a suspicion or a fear of red running traffic through a residential area. And we investigated this in depth. And with we, I have to say us, so the consortium, the technology guys, the traffic engineers, the data specialists. But what's really nice here is that if you open up this data, citizens will do analysis themselves. So if you open up the data, if you give them the tools, if you train them how to interpret data, you will get beautiful analysis from the citizens themselves, which we didn't even do and which we didn't even know about. Actually, at the end of the project, we came across, when we had to report on our impact, we came across several examples of analysis done by citizens, which we didn't even know about. So that's the beautiful thing. So don't just treat your citizens as, how to say, passive data generators. No, they're also valuable contributors on the analysis. So the example on the bottom right is one of the cases I want to highlight a bit later. That's actually the impact of some speeding intervention, but I'll explain a bit later. The key thing I want to say is, don't just think that you have to do it as an expert. Citizens can also help with data analysis from their local context, and if they have the tools. And then final thing is to be able to act upon the data, to be able to realize some change. So again, we considered WeCount a success at the point that we were not going to be the bottleneck for this type of output. And I think there are some hints and some evidence that this is the case. So like I said, we found out at the end of the project that there was like a small article in the newspaper in Barcelona on the introduction of a speed limit as a cause of a small local community who was using Telraam to demonstrate that there was a speeding issue. The only thing that we did was to give them the sensors, enable them, give them some tools, how to interact with the local authority, and that's it. We did not interact with the local authorities. No, we're citizens. You have to enable them to do that. So we've got quite some evidence that this worked. So this example here on the top right is from, I think, El País. In Barcelona, I think it was. And this is the example of Leuven. There's also on the bottom right here a few data specialists who did also some nice things in schools with I don't know what the ages were. I think 12 to 14, which has also been used later on. So again, don't underestimate citizens and also pupils to work with this type of data. I want to show, I'm not sure how much time I have still. I want to show 2 or 3 data cases. So one of them was the impact of the COVID-19 lockdown. So we actually had a few hundred devices active before the lockdown, which was mid-March 2020. So this allows us to basically have a cover tracker, see how traffic behaves before and after this intervention. There was a lot of talk of non-compliance to the lockdown, so traffic going up smoothly. So that's what we tried to monitor. We didn't see this. First of all, what we did see was that we were on the percentage, the exact same of traffic reduction that you could see from Google Mobility or Apple Home or all these other appliances, all these other service providers who had the cover trackers as well. So we could see exactly the same level of reduction, and we could not see a creeping increase. So this is blue line here, but after I think end of April, it started to go up again a bit, so non-compliance increased. Then what's interesting here is that when you had cover trackers on impact of traffic, it was very car oriented. So it was very much okay, how is car traffic behaving? Is it going up or down? Now, what you can do with Telraam, obviously, is you can also look at the other modes. And what we could see, and that's this big red circle here, well, not circle, but this object here. What you can see here is that actually active travel, so the green line here, cyclists, went up even higher than before lockdown levels. And in Belgium, there's clear correlation, because after a few weeks, there was an instruction from the government, okay, don't go to work, stay at home, but at least go out and stay active, health. So you have to go out. So there was a clear correlation at the timing of these instructions or messages, and what we observed in the traffic volumes of bikes. And obviously you don't see that with counting loops or Google data. So very nice case as well. And this is another nice case. I already hinted at it in the data section. So the example here is this is a main axis in the city of Leuven where I live, so a bit east of Brussels in Belgium. It's an entry road to the city center. It's a 30 km/h road, but obviously the speed limit is not adhered to. So what you can see here is, if you take the red line, it's the percentage of cars which are speeding beyond 30 km/h. So the level of compliance towards the speed limit. Now there's been a citizen activist group for, I think, years already, who have been, advocating and pushing the local authorities to do something about it. So what happened? They took part in the Telraam project and in the Telraam pilots in WeCount in Leuven. They installed a sensor. I should say one person installed a sensor of this activist group, and they demonstrated the level of non-compliance towards the speed limit towards the city. They had the dialogue open, and now they had data to prove it. Okay, so they were able to convince the local authority to do something about it. What did they do? They did two things. First thing is they installed a digital speeding sign. So when you pass by your car, you can see like a smiley speeding, yes, no. And the second thing is they installed a speed bump. Now, the beautiful thing is with Telraam, you can now see if these things work, yes or no. And you can actually see on the time, so exactly at the date when these interventions were done, if these work. So the one was here, the first one, the introduction of this sign was done at the end of May. And you can see that compliance improved about 10%. So where it was 50% here, it went to 40 or 35%. So if you ever wonder if these signs with speed, if they work, apparently they do. So that's at least one evidence we have here as well. And then the second part is the installation of this road bump, like it's a permanent cushion. And then obviously the compliance increased much higher, because if you drive faster, then you've ruined your car. And what I like about this, and you'll have noticed all these things here are in Dutch, that's because this analysis was not done by us, but by somebody else, but by a citizen in this activist group. So you had, in this group, you have one person who installed the sensor. You had somebody else who was in dialogue with the local authority, who was very knowledgeable and very, I would say, wasn't scared of the local authority. So she really had a strong voice. And then there's somebody else who's very quiet, but he's very well with Python, very well, can do very nice things. And he made this, and they made this all by themselves. The only thing that we did was enabling them, giving them these tools to do that. So it's one of my favorite stories, what that came out of WeCount. It's small, but there's plenty of those. Then there's another one, but I think conscious for time, I'll skip that fast. So there's one example here of the impact of road construction works in a city in the vicinity of Antwerp. And you could see, basically the story here is that you could see that as the roadworks, which took about a year or so, and they went via a deviation, a bypass route, that traffic did not go back to normal after the lifting of the work. So there was a permanent reshifting in traffic, even though it was better to use the main road. I'll invite you to read the blog post in detail. Last slide, and then we'll jump to the questions. So for us, WeCount key learnings, it's not on the technology side, it's more on the citizen science side. So this is for, let's say, a citizen science audience, or anybody who is willing to or has the balls to start with this citizen science project. Let's say there's 5 key takeaways. First one, most importantly, technology equipment needs to be simple. So even though we made a very simple onboarding process with this Raspberry Pi thing, in principle, it's not hard. You still lose people over even the smallest technology hurdles. Make it simple. So with this thing, it's really just plug in, scan QR code, and that's it. So this is key. If you want to reach a big group, technology needs to be simple. Second one is actually a quote from our participants. The more involved you are, the more likely you are to act. So again, this is the benefit of self-installation. If somebody's going through the trouble to install a sensor themselves, she feels like she's generating data and insights. The sense of ownership is much larger. And then they're also much more willing to, okay, I'm not going to do something about this. Rather than if you're going to pass by and you're going to install a sensor for this person on this one, he's not engaged, he's not part of it. So involve them, and then action will follow. I've mentioned the third one, I think several times. Citizen science is not passive data collection, definitely not. I mean, citizen science is also data analysis and doing something with the data. And then this is more of a message to vis-a-vis, I think, local authorities who want to do this, or maybe even a university. If you start the citizen science project, you have to commit. Your participants will expect this from you, and they will call your bluff if it's going to be like window dressing, and then it will backfire spectacularly. So if you want to do citizen science, you have to also show and demonstrate that something will be done with the data that they're generating, and it's not just playing around or yeah, I'm going to do my thing in any case. No. You have to commit, and you have to be serious vis-a-vis your participants. So I think that was it. I hope I didn't went too far over time. In any case, I have plenty of time for questions. So Hubert, over to you.
Thanks. Really, thanks a lot, Kris, for this fascinating and actually also very inspiring presentation. It's really great to see like how decentralized technology can help to empower people, to empower communities. If you have any questions, you can either use the chat or directly virtually you raise your hand. Actually, we already have several questions. One from Anthony, actually, who is curious about calibration and validation of the counts. How do you do it, and how do the results compare with more traditional sensors methods? Does that even matter given the other goal of co-design, community building, etc.?
Good question. I mean, if you say low cost citizen science, I mean, that's red alert for, okay, but they compromised on quality and so on and so on. So first, again, citizens to the rescue, because in terms of validation, you could just do manual counts, and we could ask participants if they were in doubt, can you do a manual count, and we'll compare hour by the hour to see if data is correct, yes or no. In fact, we've had quite a lot of validation points just with this method. And then purely on the accuracy, and that's more technically. So I can also say with S2, but the current sensor now, so the Raspberry Pi based system, this one, has an accuracy of about 85–90% for cars, which is more than enough from a traffic engineering point of view, especially if you have a long time series. So it's not accurate enough to for example, help with traffic light planning, because then you need really accurate data. But it's more than enough to see impacts of change in circulation and so on. So 85–90% for cars. It's a bit less for pedestrians and cyclists because you can have merging of objects there, and there's more risk of misclassification. But what I think is important for a citizen science project like this with Telraam and low cost is to be completely transparent about it. So this is a low cost technology. Here is the evidence what the accuracy looks like. You can trace it back. This is the count that we did. We compared it with pneumatic tube, which is a more conventional technique. We have got a nice blog post about that to explain that. So it's more about the perception thing, I think, rather than an accuracy thing per se. Because if you have a long time series, you can do a lot already. I mean, the volume of data can compensate actually for the per hour data quality resolution. You're muted, and don't forget.
Sorry. Question from Antoine, who is asking, has any public authority reached out to you to use the sensors or analyze the data?
Yeah, and yeah, this is now I didn't dwell on that in detail, but this is the model that we've strived for. So in WeCount, we had the budget, the funds to set up this ecosystem and to start building it. How we're working now is in this triangle. So citizens want to have a sensor, but they're not paying for it. I mean, it's still a bit expensive. I think 100, 120 euros for a single device. But local authorities see the value of the data and the citizen interaction. So we've actually made a format where we operate as a citizen science service provider. So we help local authorities deploy small networks of 20, 30, 50 devices, and we just facilitate them, and we are a facilitator. And that's the model that we're doing now. So basically, local authorities pay us for the equipment and some service, and citizens take part, and they get the devices for free and generate data. That's the weird value triangle, let's say.
And I was also wondering, Kris, because from what I understand, actually, WeCount, it's a kind of methodology. It's a kind of, you know, like, we could say like a philosophy, right? And do you have like other data that you can collect, you know, like, so you talked about traffic data, but do you have in mind other data that you would like to collect with WeCount? I don't know, air pollution or anything else?
In WeCount, there was actually also an opening for air quality data. So because it's also another sphere where citizen science is very strong, but the emphasis there was on traffic, and basically because there was so much focus and interest in traffic, we've limited the scope towards traffic. But like you said, I mean, the approach and the ecosystem is quite similar for other sensing techniques. I've seen like air quality projects plenty, but also for odor collection, human sensing, also with using very similar approaches. So we've got some for academia. I don't know, again, I'm not sure about the audience, but for academia, we have on Zenodo our practitioner guide that you can replicate, let's say, the WeCount method for other citizen science sensing techniques, which at least involve data collection with citizens. I'm just going to paste in the chat here a link to our a blog post on the sensor accuracy. Yeah, I think it will demonstrate how open we are on accuracy and possible inaccuracies.
Okay, so thanks, Kris. Last question, which is a very practical one. Anthony, which is based in the US, is asking when can we order Telraam for shipment to USA?
You can now. We're starting our first project in Savannah, Georgia, for the EPA. So they're gonna use this case as a pilot project to see if this works. It's like a citizen science group within the EPA. So yeah, I mean, there's nothing which would limit just to Europe, or it can also be US.
The reason I asked was that I went to your I guess your preferred vendor in Belgium only ships to EU. Yeah. So if there's another in the US, let us know.
You have to contact us directly, then we can set something up. So that's fine.
Okay. Awesome.
Because the vendor, so which is Cotron, I mean, they're basically a distributor of the hardware, which is a Raspberry Pi. So you can also buy the equipment at the Pi Hut or something in the US. So, but if you want to do a project, it makes much more sense to check with us, and we can also do everything on equipment and service.
Okay, sounds great. Well, thanks a lot, really, Kris, for this amazing presentation, inspiring session. That's already the end, actually, of the episode. It will be available on our YouTube channel in the coming days. And next week, we'll have our third episode. It will be with Sarah Berry, and we are going to talk about the quantified canopy, and it will be moderated by Anthony Tensen. Bye, everyone, and have a great day.
All right. Thanks. Bye-bye.